Okay, on this lesson, we're going to be reviewing the function transformations on absolute value, square root, cube root, cubic, exponential, log, and rational. So we're going to be reviewing these from the beginning of the school year. So a composite transformation occurs when two or more transformations are performed on the graph to produce the new one. So we're going to be given some information and we're going to fill in the rest of the chart. So the functions f and g are graphed on the same grid. You're going to use the graph provided to complete the table. Remember, f is always your parent function. So we're going to look at f first. Notice this is cubic. You have to know that. So you can refer back to your last lesson. And notice that it is shifting left, 1, 2, 3. And then it's going down to get to the new one. It's going down 2. So those are your transformations from your parent function to your new function g. You're going to write your equation of g. So we know it's cubic. You have to know that. So I'm going to have g of x equals, cubic parent function is x cubed. So I'm going to be going left 3. So in parentheses, I need x plus 3. Remember, it's the opposite. Then I need the cubed on the outside, and then the down 2 would be minus 2. We're going to find the domain and range of f, which is your parent function. So domain of the original is either negative infinity to infinity or all real numbers. And then same thing for your range. Now we're comparing now we're looking at the domain and range of g. So here's our g. Notice it's the same exact thing because our arrows are continuous in all directions. So anytime we have a cubic, our domain and range, no matter what the transformations are, will be all real numbers or negative infinity to infinity. All right, let's take a look at another example. So example 2, notice, look at f, that's the parent function. This is square root. So that's square root of x. And then notice that it went down 1, 2, 3, 4. And then also notice that it's going the opposite direction, which means it has been reflected over the y-axis. So writing our equation of g, there's a reflection over the y-axis, which puts the negative inside the square root. So you're adjusting that x value, so negative x. And then down 4 would be minus 4 on the outside. So remember, when you're reflecting over the y-axis, the negative goes on the inside, whether it's inside parentheses, inside a radical, whatever it may be there. Okay, so looking at f, which is our parent function, domain, can either put 0 to infinity, or you can put x is greater than or equal to 0. And then your range, if you look, notice it's the same. So 0 to infinity, or y is greater than or equal to 0. Now looking at our transformed g, so looking at g, notice our domain is from negative infinity to 0. Or you could put x is less than or equal to 0. And then our range, if you look at the y-axis, notice 1, 2, 3, 4. It's at negative 4 and everything above it. So you would have negative 4 to infinity, or y is greater than or equal to negative 4. So again, on the domain and ranges, I don't really care how you write it. You don't have to write both. So just pick whichever method or way that you would like to write it. Okay, the next two examples, it says the function g is obtained by transforming f. Use the information to complete the table. So it's giving us the parent function, cube root of x, and it's translated right 2 and up 3. So you need to look at, if you don't remember, you need to look at your f, or your parent function cube root of x. So the points that we used were 1, 2, 3, 4, 5, 6. So -1, -1, 0, 0, 1, 1, and then we would have -8, -2, and +8, +2. But in this case, we can't graph that. So I'm going to go ahead and I'm just graphing f first, which is my parent function. Now I need to translate it right to, I'll use a different color, right to, so go ahead and shift right to up 3. We moved our origin point. Now everything else will stay the same because there's no other transformations. So I'm going to go left 1, down 1 from that new origin point, right 1, up 1, and then we will sketch the rest of it. So there's my G. Okay, so my equation for G, we know we have a cube root. We're going right to, so the opposite would be x minus 2 under the cube root, and then the +3 on the outside because we're going up. Okay, so domain in range of f, which is our parent function. It's all real numbers. The arrow is going in all directions for domain and range, and it will be the same exact thing for our G. So on cubic and cube root today that we've looked at, it's all real numbers for both your domain and range because the arrows are continuous in all directions. Okay, example 4. We are given the parent function absolute value of x. So you need to know what it looks like. It's a v. Looking at it, this time it gives us the equation, so we need to come up with the transformations. Notice this negative in front will be a reflection over the x-axis. And then the x's are not changing because notice inside the absolute value there's nothing with the x. And then we have a +5, which will shift it up 5. All right, so let's go ahead and graph our parent function. So we did -2, 2, -4, 4, 0, 0, and then the same thing on the other side. So this is our parent function. And then we're going to use the transformations to find the new one. So I'm going to go ahead. You always want to shift first your 0, 0. So I'm going to go ahead and shift up 5. 1, 2, 3, 4, 5. And then I can worry about the reflection. Now, I forgot to put, there was a 2 in front. So there's also a vertical stretch by 2. Okay, so normally, here's our points. Normally our points are 1, 1, 2, 2, 4, 4. But since there's a reflection over the x and our vertical stretch by 2, instead of going right 1, up 1, we're going to go right 1, down 2. Instead of right 2, up 2, we're going right 2, down 4. 1, 2, 3, 4. And then the same exact thing on the other side of your V. So always shift the 0, 0 point based on your left and right translations, and then you can worry about the reflection and the stretch or the compression. All right, so that's our G, our F. Domain is all real numbers. Notice the arrows are continuous to the left and to the right. The range, however, is not all real numbers, because if you look at it, it's everything greater than or equal to 0, or you can put 0 to infinity. And then looking at our translated G, domain, same thing as the parent function, all real numbers. And then the range, notice we shifted it up 5, and it's opening down because of the reflection. So that would be from -infinity to 5, or you can put y is less than or equal to 5. Okay, let's go ahead and flip over. Now we're going to be looking at exponential, log, and rational. So on this one, example 1, it says the graph of 2 to the x, which is exponential, has been translated right 8 and up 3. So we're going to write the new equation. So g of x equals, if I'm going right, I'm doing the opposite with x. So I should be doing x minus 8 and the exponent. Up 3 will be plus 3. Okay. All right, so looking at exponential here, if you don't remember, there's always a horizontal asymptote, which is at y equals wherever that up or down shift is. Okay, so did the domain and range change? Okay, so yes, it did. The reason is because it went, if you notice, remember your exponential, so your exponential graph looks like this on your parent function. So if we shift it left 8, that will not be changing your domain, but if you shift it up 3, that will be changing our range. So yes, it did. It changed the range. From normally it's y is greater than 0, but now it's going to be y is greater than 3 because it shifted it up 3. Okay, the asymptote is the horizontal asymptote, so normally it's here. But since it shifted up 3, now the asymptote did change because it went up 3. So now it's at y equals 3 instead of at 0. Okay, so now we're going to look at the logarithmic function. So notice this one, I have the natural log. It's vertically compressed by 1/2, reflected about the x, and left 9. So we're going to write our new equation. Reflected about the x is a negative in front. Compression, vertical compression is the 1/2 in front. And then we have the natural log, and then left 9. So in parentheses, instead of just natural log of x, we need to be doing natural log of x plus 9. And then we would not have anything after that because there's no vertical shift. So normally our logarithmic, remember, looks similar to this, and we have a vertical asymptote. So our domain, we did shift. Okay, so we did shift left 9, so our domain changed. So instead of the domain being x's, what would that be? X is greater than 0. So it went from x is greater than 0 to, when we shift left 9, it's going to be x is greater than -9. The range, however, did not change because it's all real numbers. So remember exponential, logarithmic, domain, and range. Domain of exponential is all real numbers, but the range of logarithmic is all real numbers. Vertical asymptote is normally at x equals 0. So since we did shift left 9, it did change that vertical asymptote. So now, because it went left 9, so now it's going to be at x equals -9. Okay, now we're going to look at rational. So rational, remember we have a fraction. Here are your transformations if you need to refer to that. Rational, we do sometimes have both horizontal and vertical asymptotes. So it says the graph of 1 over x, which is the parent function for rational, is vertically stretched by 3 and then shifted 5 units to the right, 1 unit down. So my function g, vertically stretched, if it's a vertical stretch, that goes in the numerator. So I'm going to have, instead of a 1, I'm going to have a 3. And then it shifted 5 units to the right, so that would be x minus 5 in the denominator. So with your x, you need to put x minus 5. And then down 1 would be minus 1. So normally on rational, if you don't remember, looks like this, 2 separate pieces. So if we shift our, remember our domain and range on rational is what it cannot equal, because there's 2 pieces that it can't equal. So yes, actually both of them changed because we had a horizontal shift and a vertical shift. So my domain was originally x cannot be 0, but now it's x cannot equal 5, because it went right 5. My range is normally y cannot equal 0, but since we went down 1, now it's going to be y cannot equal negative 1. And then we're looking at the asymptote changes. So yes, they both changed. So my vertical asymptote is now at x equals 5, and my horizontal asymptote is now at y equals negative 1. Okay, so you have to refer back to that graph to know what exactly is happening. Okay, so now you're going to work on the assignment. If you have any questions, you can ask next week, but get done as much as you can, turn it in, and then again, if you have any questions, we can get those answered next week.